In this video, you will learn about indirect measurement. Indirect measurement is when we use the measurement of another object to find the height or length of an object that is maybe too tall or too difficult to measure. When we use indirect measurement, we actually use the direction of the sun and the shadow of the object on the ground to measure that object's height. The idea here is that if the sun is at a certain angle in the sky and it hits two objects at the same angle, the length of that object's shadow is proportional to its height, as long as the sun and the shadow is measured at the exact same time of the day. So in this example, it says that they're trying to measure the height of this clock tower, but it's too tall to do. So instead, they take a stick that's a certain height, in this case 3 meters, it's a 3-meter height stick, and they stand it upright, and they measure the shadow of the stick on the ground, which is 1.5 meters. So they say at this time of day, the length of the shadow of the stick is half as long as its height. And so they come to the conclusion that as long as I do this at the same time of day, the same should be true for the clock tower shadow, because the sun hits everything at the same angle because it's at a certain height in the sky. So if we know that we can measure the length of the clock tower shadow because it's on the ground, then we can easily compare, using that idea of them being proportional to one another, to figure out that missing height of the clock tower. So since we know that the shadow of the stick is half as long as its height, the same is true for the clock tower, making the clock tower's height 16 meters. Now you can use that logical reasoning like I just explained, or you can use a proportion. So we can say this is our missing height, and you can actually set this up a couple different ways. You can say the height of the clock tower X over its own shadow, 8, equals the same ratio as the height of the stick over its own shadow, which is 1.5. You can look at the height versus the shadow and the height versus the shadow. Or you can compare the height of the clock tower to the height of the stick, so that's X over 3, and then you can compare the two shadows, which is 8 and 1.5. These will actually give you the same answers, although we are slightly differently comparing the two. You can set them up either way. Take a minute to give these problems a try. If you're having trouble determining how to set these problems up, drawing a quick little diagram can be helpful. And don't worry if you're not an artist and can't draw very well. You don't really need to be able to draw, for example, this Ferris wheel. You can simply draw something like that and label the height as 136 feet, and then just a little shadow on the ground, which is 34 feet. And then it says the height of a man. You can go ahead and draw yourself a nice little stick figure. We know his shadow is 1.25 feet, and it wants to know how tall the man is. In this case, he is 5 feet tall. Second example, a radio tower casts a 120-foot long shadow, and at the same time a 12-foot tall basketball hoop casts an 18-foot long shadow. How tall is the radio tower? You don't even, like I said, need to worry about your drawing. I just sometimes even just draw lines here. So we know that the shadow is 120 feet long. How tall is the radio tower? If the basketball hoop is 12 feet tall, and it casts an 18-foot long shadow. So this one is actually, the shadow is longer than the height. So maybe my drawing over here is not so accurate, which happens when the sun is starting to set, right? So as it's lower in the sky, let's say the sun is here. Here we'll do it's hitting the basketball hoop at a more shallow angle, causing the shadow to be longer. And same with this one. It's going to cause the shadow. It's hitting at the same angle. So that's what makes them, you can see they kind of look like similar triangles there if you kind of fill in the angle of the sun. So here we have maybe x over 120 and 12 over 18. And we know that the shadow should be longer than the height. So keeping that in mind when you're solving, paying attention to the ratio or the idea between the shadow and the height, which one's bigger, that should help you to determine if your answer is accurate or reasonable. So you could do x over 120 and 12 over 18, or as I said, you could actually compare the heights. X over 12 equals 120 over 18. Either of those will work, but your answer would be a height of 80 feet for the radio tower.